And why did they decide for the hot staging? Because as I was reading about it, the hot staging was mainly used with the Soviets, right? With the N-1 rocket in
Yes.
late 60s. Then the N-1 rocket actually never ended up doing any hot staging because it didn't sort of get up and get to this section where they could like separate
Yes.
these, like they had even 5 pieces to separate. They didn't separate even
Yeah.
one,
Yeah.
right? And
That was a
in
behemoth. Yeah.
yeah, and in the end, it was a sort of sad story because they ended up suspending the program because the main designer or the engineer Korolev, he died unfortunately. So I wonder, why did they get so inspired by this hot staging?
Okay. There's a couple reasons behind that. First, hot staging, I think, is also used on the Soyuz. I think so. Some of the Russian boosters use it. Also, some of the American boosters, the Titan missile for sure, it did it, and they launched astronauts on top of that one. So it can be done, and the real reason is because in order to put rockets up into space, you need to eliminate as much mass as possible, and then you couple that with the fact that Elon believes in the best part is no part. You put those two things together. What they're trying to do is eliminate parts and processes that you don't need. And in order to do staging that's not hot staging, you need to add some other components, which are called these ullage motors, which I'll explain in a minute what that is. So it adds, some extra mass, some extra process, and a little bit of inefficiency on the way up, because when you do the staging, you have to get the separation, and then you have to make sure you're separated far enough before the other stage lights up, just to make sure the exhaust plume doesn't either cause damage to a booster. And in the days of the Titan, they didn't care because you were throwing the thing away. So what if the booster destroyed? But you would like that thing to survive on the way down. At the same time, you might have some blowback issues that go to the second stage. So you want to make sure you're separated enough that it's safe to go ahead and do that. But during that time, you're experiencing something they call gravity losses. So even when you throw a ball up in the air, once it's released from your hand, it's no longer being boosted. It's still going up, but it's slowing down. So it's a sense decelerating until it finally gets to zero velocity and has to fall. So the rocket stack is still going up, but it's starting to slow down. You're losing velocity. And it's not so much that, and you're not losing any altitude. So it's not like it's falling out of the sky. It's still going up, which is great. You're making forward progress, but your velocity is dropping. And to get into orbit, it's not about how high up you go. It's about how fast you are going. So yeah, you got to get above the Earth's atmosphere, but anyone can get above the Earth's atmosphere. There's all sounding rockets and stuff like that do it all the time. The problem is they don't have the velocity to go into orbit. So you're going up and suddenly your velocity is beginning to retard a little bit. And as it drops down, and then you start up that second stage engine, now you have to make up what you just lost. And so it's I spent all this energy, all this propellant to get up to that speed. And now suddenly you're backsliding a little bit. And now we have to make up for that. And then we can advance. And it's a strange kind of rule that's going on of your, the momentum that you're gaining is as mv, but the energy you need goes as like v squared. And so it's really a huge penalty when you stop thrusting. And the Falcon 9 stops thrusting for, I think, 10 to 11 seconds before it starts up and gets going again. And of course, it's not just starting up and going. And a lot of times, like you start it up and you got to rev it up, and it might even take another second before you really start making good forward progress again. So the idea of the hot staging is to try to reduce that interval as much as possible. Now, they can't make it exactly zero. There's still a little bit of gravity loss in there, but they're trying to reduce that. SpaceX, or Elon has said, and even SpaceX said in the live stream, that it could result in a 10% increase in cargo, in payload capability, which, I mean, that sounds
when
fantastic.
You go to Mars, it's worth it, right?
Anything, and putting anything in orbit, if that's true. I know there's advantages, but a couple of guys in the Twitter threads, and we're kind of rocket nerds too, and we're looking at that, and we just don't see how they're getting 10% out of that. We believe they could get a couple percent. And a couple of percent is always good. I mean, believe me, in rocketry, if you can get another 1 or 2% out of something, that is great.
That's awesome.
10% it would be absolutely fantastic if that's true. Now, it doesn't come without some kind of cost, because the other aspect of it is something that we call why you need the ullage motors. And so I'm going to use my prop, which is a water bottle. Okay.
Awesome.
So this is a tank. And the tank normally is completely full at the top. And then as you start going up, your tank starts getting empty. And this empty part is what you call the ullage. That's what's kind of left over. And then you have your fuel down here that gets smaller and smaller. Now, we all know that if the air in here starts to disappear, the bottle's going to collapse. And these tanks are designed such that they will collapse on themselves if they're not pressurized. So you've got to pressurize that. So as you're sucking this down, you have to make sure that you replace it with some sort of gas. And there's a couple of ways of doing it. One is you can refill it with helium. So the Falcon 9 has helium tanks, and helium is great because it's very light, it's non-combustible, so it's not, it's inert, and it likes to stay as a gas. It's really hard to liquefy helium. So you go in there and you pressurize it. Now you get the pressure to help push it also down to the bottom and into your plumbing. And then you've got the pumps in there that will suck it through and pressurize it even more before it goes into the combustion chamber. But the main thing is you've got to keep that down there. So now when you're going up, if I release this bottle, basically it's weightless for an instant. And you can see there's some examples. I think you'll see, I think it's Brian Greene. He was on the Colbert Show like a few years ago showing a physics demonstration. He was up on the balcony and he took a can of Coke and he put some holes in it. And you could see everything was spraying out. And then as soon as he released it, it stopped spraying out. Because when he's holding it, it's actually feeling the effects of gravity because it's stationary and gravity is pulling it down. And as soon as you release it, it's weightless, which means there's no pressure on it. And that's why it wouldn't spray out anymore. So during its free fall, that's not happening.
But if you shake it, right? If you shake the Coke, it will spray.
Oh, yeah, that'd be even worse. I mean, he's not trying to, he wasn't trying to shake it. And I think it may not have been Coke. It may have been actually water because that could have been a problem if you had carbon dioxide in there. So the idea is it starts to fall. And as when you're in free fall, and we experience weightlessness all the time, in an elevator is an example, when it drops all of a sudden, on a trampoline, even walking, well, maybe not walking because you always have one foot in the ground, but when you're running or jogging, for an instant, you're weightless. You just don't realize it. And then you feel the impact. And so you don't have to be in orbit to be weightless. All you have to do is be in free fall. And that's what happens. As soon as you stop thrusting, as soon as you stop pushing up like this, your whole rocket is in free fall. And when that happens, that means the fluid that's in here is free to go wherever it wants. And it might start to go up rather than down. And everything kind of mixes around. And then suddenly you start getting air bubbles and everything else down here that you don't want. And then when you go to light up your engine, suddenly there's no fuel. It's starved. Yes. So if it's almost like your tank is empty. It's the same thing as having an empty tank.
So this is what they wanted to avoid with the hot staging, right?
You always have to do that. This thing is every single rocket. So if you look at some videos of old rockets, like the Saturn V has one of those iconic ones where they show the separation of the second stage and you see this ring falling off. And when that ring kind of falls off, you look around there and you'll see that there are these they're actually the ullage motors are on there. How do you describe them? They're kind of like these thin cylindrical things that are on around the side. And those are actually solid rocket boosters. And a solid rocket booster is basically like a firework. It's just like fancier kind of chemistry that they use in there. But and you light it and it goes.
Oh, it does.
Versus, yes. Yeah. So that's what a solid is. A solid rocket motor is the simplest motor. It may look fancy, like those space shuttle solid rockets. They're very easy. They're just basically rings of this material, which is like rubber and a bunch of other stuff. And mixed into it is all of the oxidizers you need. So gunpowder is a solid, is used in solid rockets all the time because you don't need oxygen because the oxygen is in the chemical composition. There's all the stuff that you put in there, and all you need is a heat source. And once you get that, boom, it goes, and it will just burn and burn and burn. For liquid fuel, we need to actually pump the liquids in there. We need a nozzle. A solid is really easy. You have this long chamber, which is full of the solid material that's going to burn, and then you just make a simple nozzle out of it. And you start that thing, and once it goes, there's no stopping it. But the beauty of it is it's very reliable and it's very simple. So once you start it, it goes. And you make sure you have enough in there. If you need like 2 or 3 seconds burn or 10-second burn, you have that. So on that ring are actually some small rocket motors. I mean, no one kind of realized that. And they had to light up before the Saturn V second stage would light up, because what happened is it give that little push. It didn't have to be 1 G. It just had to be enough to overcome a G to just, just enough to make sure you get the settling of the propellant. So once the propellant would settle down at the bottom, now the intakes would be able to get it, and then you can start up. So you need the fuel down there to get the start, And you don't want bubbles, because if bubbles get in the fuel line, they're going through the turbo pumps, and the turbo pumps are spinning extremely fast. And if suddenly you ingest a bubble in there, a really big one, that turbine will suddenly overspin. And then when that happens, it goes boom, and then there goes your power head, and then you've lost an engine. And then you get an engine fire, and then you get this other stuff that's kind of going on. So those are the things you want to avoid.
Was it a case, just tempting me to ask, the case with Challenger, which exploded?
Yes. So what happened in Challenger is that it was the solid rocket boosters. And the thing is, it's the way the space program is run in the US is that in order for people to agree with this, every state has to have like some skin in the game. So Utah needed to provide something. So Utah was making these solid rocket boosters. And these boosters are so big, you got to transport them from, high in the mountains in Utah all the way to the Cape. How do you do that? Well, you make them in little sections. So they had 4 different sections, and you had to stack the sections together. And when you stack the sections together, you have to have like gasketing between them to hold them together. So you build it that way. Now, if you manufacture this, maybe say on site at the Cape, you can make that thing as big as you want. And, you don't have to worry about it going under highway underpasses or bridges or anything like that. So that's the way it was. It would be stacked together, and they launched in cold weather. It was 27 degrees in the Cape that day, and they were warned by all the engineers never to launch. It even said right in there that one of the launch criteria is it cannot be below this temperature. Why? Because at those temperatures, the gasket, the material in there, starts to get compromised and does not work as well as it should. So that meant the gaskets that were ready to fail. And as they went up, one of them started to fail. And when that failed, then some of the hot gas, rather than going down that way, became a blowtorch going towards one side, right next to the hydrogen tank. And then it bore a hole in the hydrogen tank. And then once that happens, because, if you take any, like a balloon, because basically they're all called balloon tanks. It's not so much like I poked a hole in this, not much is going to happen. But I blow up a balloon and I poke a hole in it, it just decides to pop and its contents will come out. So these tanks are extremely thin under very high pressure. And if you poke a little bit of a hole into it, it will just tear apart. And now suddenly you have like all this hydrogen just all of a sudden there, and you've got a heat source, which is the flames coming out of the other, and boom, just like that. And then of course you get the liquid oxygen tank, which if you didn't already have enough oxygen, now suddenly you get more than enough. And it was considered to be the explosive force of a small atomic bomb. That's how much potential energy was in there. And so, it tore it apart really quickly. And that just shows how quickly something can go wrong, and why you have your procedures set up to make sure you don't try to launch under conditions you don't launch under. So, And now you got to slow me down here, Lenka, because, I just kind of go and go. So if you got questions, just please interrupt.
I like it. That's great. Thank you. You explained all very well. It's not easy to understand it, actually. Even if you watch multiple YouTube videos, it's still hard to understand.
Now I haven't even finished on the whole hot. So we're kind of getting into the hot staging. So the idea is that hot staging or not, you've got to do something to push your booster forward before you start it up. That means you have to put these ullage motors on there. The ullage motors are added complexity. And Elon doesn't want to put those on there. He wanted to get rid of that because that would be like a cost savings and mass savings. So that means you need something to push it forward. And you don't have the RCS controllers on here or any ullage motors to be able to push it forward. So how would you do that with the second stage? Well, you use the first stage to keep it pushing forward and then allow it to light up. And that means you have to do it as a hot stage. It has to be connected when you do that. So if you're going to be connecting it together, you have to put a ring in there. So they had to actually add a 5-ton ring between the two. So it got a little bit taller than the first one. And it had to be vented because that exhaust has got to go somewhere. If you close that thing off, that whole thing is going to explode. There's no doubt about it. So you have this ring, and the ring has to be designed in such a way that you have enough venting in there to make sure everything vents out, but you've got to have enough strength to make sure it can support the weight of the entire stack. So, that's a mechanical design challenge there already to be able to make sure you have that working right. And part of the ring was they had heat shielding on top of it because you used to have the pressure dome of the first tank. And you don't want the plume from the second stage that's going to be coming down there for several seconds. It's going to be this big blowtorch on there. would just cause that thing to rip apart. So that means you had to have like another dome in there that acted as heat shielding between it. So the question mark, was that dome going to survive? Going through something like that? Was it going to rip everything apart as a result just to get that benefit? Now, Elon, he's trying to get rid of mass here, right? It's like, well, you just added 5 tons. So it's like, okay, does that mean the old motors weigh more than 5 tons? So there must have been some crazy calculations to say that 5-ton weight penalty or mass penalty was worth the effort to go through with all the potential dangers that could be going on. So it seems like they were able to get the forward thrusting for that. So what happened is on the way up, all 33 Raptors were burning. And then right at the end, they shut down all of them except the interior 3. And those interior 3, they also dropped down to 50%. So that was like just enough to keep the stack. The stack was starting to slow down. So there was technically a little bit of gravity loss, but there still was enough forward thrust that you wouldn't get what they would call the propellants unsettling happening. It wasn't going to start floating around or anything like that. So it was pushing enough that the second stage was able to light up. We saw it lit up. And of course, they had to light up all 6. We were speculating, it's like, oh, they'll light 3 of them, get separation, and then do the other thing. But there is a problem with that. And that is, as the first stage is thrusting up, it's pushing the whole stack up. And it's having to lift itself and the second stage. Now, at this point, the first stage is getting pretty close to empty. So it's pretty light. And the second stage is probably the heavy bits right now. So it's kind of pushing that whole stack up. Now, the second stage separates. As soon as it separates, suddenly the first stage is no longer having to carry the second stage. And it's going to say, whoa, hey, now, it's suddenly like you're lifting a weight. Like, and suddenly someone pulls the weights off. Woo, you're going to like really be able to accelerate quickly. And that was the concern, is they had to balance that second stage was pulling away faster than this thing would suddenly lurch forward. So it was going to, and so it went, pretty quickly, that it added a little bit of velocity suddenly at that point. And the concern was, do they bump into each other? So, that's a tricky timing thing as well. And that's why they had to light all 6.
So was it the reason why the second part after exploded?
There could be. So we don't quite know why this. I mean, we knew the FDS went. We don't know why the FDS went. So the second stage was blown up by the flight termination system, and it was blown up by the flight termination system probably automatically. It wasn't a command that came in there. It detected something was out of normal, and it went. And SpaceX told us it did that. So we know for sure that was what was triggered. The first stage, I don't think anyone has officially said it was, but it looks like it definitely did. I think there's some images out there that kind of show that probably is what happened for a variety of reasons. So again, these boosters are separating. You need to have all 6 that are going on there, and everything seemed to be performing pretty well, because the big question mark is like, ooh, is the second stage going to be able to survive that? And it did, for a while. So I would suspect there's something about the hot staging that may have caused something in one of the engines to fail, and fail very late. So it was going fine. And we could see towards the very end, just as it was almost got up to orbital velocity, you start seeing some weird puffs. And then you start to see it. I mean, the methane was burning so cleanly, and you're no longer in the atmosphere, that there's basically no contrails. You shouldn't be seeing anything. So for the longest time, we just saw these bright dots. It's like bright. And suddenly we start seeing some gas emissions around there. It's like, well, that's not a good sign. That means something's going wrong. And what's worse is the gas emissions that were coming around there were not symmetric. So if we're seeing a plume, or what they call the space jellyfish, you would expect it to be nice, very symmetric ring kind of going out. But it was clearly off to one side. And it's like, ooh, okay, something is venting and not venting the way it should be, which was an indication that something is going on. And I think Scott Manley had noticed, he looked pretty close, that they were showing a graphic of the level of CO2, well, not the CO2, methane, and the LOX. And they were going down, and it seemed that the level of the LOX was just slightly above the methane. And then suddenly it kind of got below it kind of quickly, almost indicating that suddenly the oxygen was being consumed at a faster rate than it had been before, which may have meant that that's what was venting. That's what was kind of causing the problem, because something had started to fail or was about to fail on it. And it got really close to orbital velocity, very, 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 very close. And then clearly something didn't go quite right. And then they decided to terminate. Now, there could be a couple of reasons. Is that it looked like the engine just shut down, but that could have been because the FDS went off, and you lose telemetry, and of course it's going to look like everything shut down. It may have been that it was pretty clear it was not going to achieve its orbit, and at that point it was starting to head over the Caribbean, and it's a pretty big vehicle, and if you suddenly lose control of it, and it just comes down, that could, you're going over populated areas. Right. So the whole idea is like, at that point, we're not going to make it, and let's take it out. Because if, so either it would come down over the Caribbean, or if it continued to go on and it was impaired a little bit, but not quite enough, then suddenly it comes down over Africa or something like that. There's a possibility it could come down in a populated area. So the best thing is that if you decide to destroy the thing, the chunks will be so small that they are probably going to burn up on the way down, and they're not going to cause any damage. So that is, they're being very cautious, which they have to. And so in some ways, that is a success of the mission, because they were able to verify that their flight termination systems both worked like they were supposed to in both cases. So the first time it didn't, first time they pushed the button, it was like, 40 seconds later, they're waiting. And what was impressive is in the first one,
but it passed the max Q, right? It must. It passed the most pressured point.
Yes, the highest aerodynamic pressure. So it made it through that without any problem. It just, it did. When I was looking at, I ended up somewhere. I've got some posts out there showing the rate of acceleration, and it looks like they ended up going into what they call the throttle bucket. Basically, they back off on the throttle a little bit before max Q. They seem to do it much earlier than I expected. Usually you get up very close and then they back off. So it seemed they were backing off a slightly earlier time and going through. And I was like, well, that's not where it just didn't quite align up. So they might have like a different rationale on how they go through max Q, because it's more than just minimizing the amount of load on the vehicle, which is what everyone talks about. It's the maximum aerodynamic load. And there's some kind of concerns on whether the vehicle can handle those loads. But there's the other thing is that there's a lot of drag losses as a result if you go too fast too soon, because the air is too thick. And if you're going through really thick air, then all of your rocket propulsion is really going into heating the air as opposed to lifting the vehicle, because it's trying to get through that air. So sometimes it's better to actually go a little bit slower for a while. And then once you get up there, then you start going a little bit faster. And that's an optimization that they go through and they look at. It's going to depend on every single vehicle, every single trajectory on where that's going to be. It's roughly around the same place. I think the 73-second mark, somewhere around there, 73, 75 seconds is where it's going to be. But the throttling back, they throttled back, and then it looks like they're accelerating a bit, but they're actually, they're accelerating. They're not adding more thrust.
Just to specify, now we are talking about the first one or the second one?
The second one, the second one. The first one was like, they were sputtering all over the place. I mean, it's like, I should bring it up here. I can go ahead and share on the screen a couple of images showing kind of what the performance was like. So I grabbed some of the numbers. These are going to be kind of some boring graphs, but we'll go ahead and I'll try my best on this. Before I do that, I just need to make sure I remember to present. So we'll come on up here. I'll do a screen share the screen. And I want to go ahead and share the entire screen. And there we are. Okay. So I think, we're probably seeing us in the show here. And now, so these were some graphics I put together. This one here, these are 4 frames just before the first stage rutted. So this is where everything is going fine, sort of. Things are looking a little bit funny on the tail end here. So this is attempting to do the boost back burn, and this is the top of the vehicle. This is where the grid fins are. Okay, so that's that frame, and then exactly 1/30th of a second later here. So you see something is exploding right there. And then 1/30th of a second later, you see this. And then the next 30 seconds, it's like completely engulfed. So you had to really catch it. And that's about the position of the flight termination system. So you see, it didn't explode at the end. It exploded in the middle, which is why it went, which is why my suspicion is that that's probably what they were using. And this is the other thing is Edison failed 10,000 times, allegedly. So, he had 1,000 unsuccessful attempts at inventing the light bulb. So that's the nature of engineering, is that you try and fail and try and fail. And so, I mean, he didn't consider them failures. The popular press, of course, always likes to look at that. It's like, no, that's how you make progress.
I even think maybe sometimes they claim that it's because they don't like Elon Musk. I even sometimes think it's also because this like sells better than like, you know what I mean?
It's
negative
clickbaity.
News.
Yes.
Yeah, exactly.
It's part of it's clickbait.
It could be
Part of
both
they don't
together.
like him.
Yeah.
And there were people who also didn't like Edison. It's the same thing. I just consider it to be sour grapes.
Yeah, that's interesting. I wonder now what if they need 1,000 attempts for them to actually safely lift off.
I don't think. Well, let's look at it this way. Not 1,000 attempts. They did have 1,000 changes to the vehicle. I mean, that's basically what Edison was doing: is 1,000 changes to the light bulb, and they made already 1,000 changes since the last flight. Now, the one thing is that if you remember in the live stream, they're showing the speed right here. I went through and nerdily copied down that speed and put it into a spreadsheet every second. So every time 1 second would go by, I would take that number and put it in there. And then I was able to plot it in Excel. And these like little spiky things here, that's just the fact that the telemetry doesn't quite match or it gets delayed. There's like a transmission delay and it gives you like some kind of bad data. So usually that pretty much would smooth itself out. It's not really doing that. The orange one is the first flight. And it, severely underperformed. It should have been up here where the blue one is. So the blue one is doing very good here. So we see that, it's getting up to speed as it gets off the pad, comes on over here, is consistent, and then they start to throttle back. So this is what you would call kind of the throttle bucket to go through max Q. And then again, max Q is actually over here. So I was kind of surprised that they decided to, that they go down a little bit more because if they continued rising up, there probably would have been up there. So they're deciding, we want to cut our energy losses going through the thick atmosphere anyways. And then once we pass max Q, then we'll start to ramp it up a bit more. And you'll see it does start to kind of climb up here. Whereas on the first one, rather than getting that ramp up, they were like kind of arcing over just because it was like, they lost an engine here. They lost another engine. And this one, everything goes up here. And that here is where the hot staging is happening. And what's interesting here is that for a minute, or I shouldn't say for a minute, like for an instant here, you have what is close to like 1G or negative 1G of acceleration on the booster, which would result in that starvation that could be going on here. That suddenly you do not, that it's going to cause the fluid in the tank to go up there and you would get that. So you don't want to go down that low. And again, it's hard to tell how much this was just ratty data because, to me, it looks like it should smoothly going in there. So it dipped down below what is zero right here, but not that much. So it would need to make it down underneath this line here to be considered critical. And then, so again, I'd taken some of those numbers and looked at it. And basically what this means is the full stack was feeling not so much negative G's, it's weightless. So if this gets to like -1, then it's weightless. So it's being negative is expected, but it means that now you're getting the energy losses. That's what you're trying to avoid. But it's not as big as the energy losses you would get because normally that would be a 1 instead of a 0.28. The 0.28 is better than a -1.
Okay, if I can then ask, looking at these two flights we had in April and now in November, how much progress SpaceX has made? How far are we from actually taking people to Moon or eventually to Mars?
It's a big step because now they've sort of proven that they can really do it. There's a few little things they have to work out. So again, this image here is showing not just the acceleration, but the velocity over time. So this is the performance difference that you're seeing on that first one versus, the first one is down here in the orange and the second one. So, clearly much, much better. And I think somewhere in here, I compare it to the Falcon.
So you think there was a considerable improvement?
Yes. If you look at this one here, this orange one is now the Falcon 9. That's like Falcon 9 performance. And this is the IFT2 or the launch that we just saw. And you see that they're very, very close. Now, they are going to be a little bit different because the Falcon 9 is designed very differently for what's going on. So this is only up to staging. And the Falcon 9 has, let's say, not as big a second stage as Starship does. So basically, the second stage is expected to do way more of the heavy lifting than on the Falcon 9. So you really can't say that, it's not doing well. It's like, actually, it's right about where it's supposed to be. And you can see it actually outperforms the Falcon 9 early on so much that this is the first 15 seconds of the launch. And this is the height of the Falcon Tower. And this is the height of the Starship Tower right there. Okay. Here, the Starship, you see it crossed the height of its own tower, basically just a little bit before the Falcon 9 is able to cross its tower. And in fact, you see right here, it's already crossed the height of the Falcon 9 tower way before the Falcon 9 would. So this thing is jumping off the pad much faster than a Falcon 9. Whereas the last time, you can't exactly say that. So the performance is getting very good. We just have to see what changes they are planning on doing for the hot staging. And they've got so much data. So again, I remind people that they have said this, not just one time, but many times. Everyone asks, well, what's the payload? What are you setting up there? Last time you put a Roadster up, and it's like, well, the payload is data. That's all they really cared about, is they have it instrumented. They've got enough data coming in that they know exactly what went wrong. The information is there. They might be able to salvage a few pieces here and there if they need to do some more analytical analysis. So I think we are in pretty good progress. And and this is the other thing to remember. With Artemis, that was like a little over a year ago. And that's after like a decade of delays waiting for SLS to finally launch and all these different scrubs. And they basically had to launch then. NASA kept on not wanting to launch because there was like something wrong. And they were just really afraid. They were so risk averse to go. That third attempt, they basically had no choice because it had been sitting out there for over a year and all these other things were aging. It was like, no, it's like milk that's about to go sour. Either you drink it now or you throw it out. And so it's like, use it or lose it right now. So they had to cross their fingers and actually hope that it was going to work. And it worked. And everyone's like, oh, it's excited. And I remember at that point. And Artemis 2 was going to be in April, right? Yeah, it's April. It's going to be cool. In 6 months, we'll be back here again. No, here we are a year later. And they're still talking about Artemis 2 is going to be more than a year later.
Yeah.
And because of the costs and all these other things. And if they ever get it going, they probably won't ever be able to launch more than once every 2 years. I would be surprised if they could launch once a year. They just are not going to.
They have even Artemis 3, right?
Artemis 3 is going to be when they finally do a human landing. So Artemis 2 is just going to circumnavigate the moon and then come home. So it's going to go up there for, I think, a few weeks in kind of this really big elliptical orbit.
This is on Starship as well.
No. So Artemis is the NASA project. That's the one they've been doing for years and years. That they're way behind schedule.
So do you think Starship is going to surpass them?
They could. Yeah. They could. So for the next launch does not require a lander. So what Starship is important for is the lander system that NASA plans on using. And I will stop sharing for a second so we can see each other. Here we go. And that's better. So Artemis is sending a crew of 4 to the moon sometime next year. And I don't know. I don't even bother knowing or looking at the launch date because it keeps on slipping. So it's like allegedly next year they're going to attempt to do it, and they're going to repeat what happened in Apollo 8. They're basically going to we'll go around the moon a few times and we come home. And then they're hoping, and again, they don't know. They always were saying, by 25, maybe it's 26, maybe it's 27, they will actually land. But there's so many other things they have to do. SpaceX is one part of it, but these other things that they have to prove. And SpaceX is just providing the lander. And so maybe that happens in 26 or 27. And that's why the Starship is so important, because if we can't get the lander up there, then that's a big problem. So that's why the politicians are probably starting to lean on FAA. They're just like, come on, just stop worrying about the chances of the Starship coming down and landing on a shark in the middle of the Gulf. It's like that was like one of the concerns they had. So there's all these this bureaucracy. Yeah, seriously, that was one of them. That was one of them. They had to make a calculation.
Who wants a shark to die?
Well, and see, evidently it's a really bizarre, one of those Kafka-esque kind of things where SpaceX had to make the calculation to prove to them that there wouldn't be a chance of that happening. And the reason they're so concerned of it is because the shark populations are declining in some areas because the shark fin is a delicacy. And so fishermen go out and try to find the sharks to do that. So SpaceX needed the data that the Fish and Wildlife Service had about the shark population in the Gulf. the thing is, that's like proprietary data that they couldn't give SpaceX, because if they let it out, they were afraid then people would know what the shark populations of the Gulf, and they would come and start. And it's just like, okay, so how are we supposed to prove, It's like, and the chance is like 0 that's going to happen. I mean, you know that it's going to come down there, but we're exploding ordnances in the water all the time. And there are marine populations that are around there that are being, that are suffering as a result of that. And
it could be even political, right? Like,
yes,
he is having so many issues now, unfortunately.
It's absolutely a silly calculation on something like that. Now, there are plenty of pleasure boats around here that hit dolphins and hit manatees all the time, and we're not suddenly saying, oh, we got to ban all the pleasure boats. Maybe we should, I don't know. But so that's why how ridiculous it gets of trying to stop it. But they have such a backlog of Starships and boosters and Raptor engines that Elon says, yeah, we're ready to go within 4 weeks. So they have everything ready. Now, I don't think they will
within
go
4
in
weeks.
4 weeks.
Did he say already?
Yeah, he said they could. I don't think they will, because first they have to do an internal investigation.
And then there's Christmas and New Year, right?
There's Christmas and New Year's and everything else. And then you need that internal investigation. And then when you get that internal investigation, they have to find out what's wrong and what changes they'll make. And the FAA will then kind of sign off and say you can do it. I don't think they can do that in 4 weeks. It's more likely it'll take about 60 days minimum before the FAA. But the Fish and Wildlife Service is not involved anymore. So the FAA may expedite it. And even if the FAA wasn't involved, you don't want to just launch it exactly the same thing. Something went wrong. You got to figure out what went wrong. And is it a simple minor changes in software, or there's some mechanical changes they have to make? So they have to figure that out. And I think it will take them 3 to 4 weeks just to figure that out, and then go ahead and start to make the changes. So, mid to late January is the earliest, I think. More likely sometime in February. But if that launch goes the way it's supposed to, it's truly a success, unless it like kills a shark in Hawaii, and the headlines will be, it's like complete disaster, shark killed in Hawaii. So if that thing goes, then they can increase the cadence at that point, because the FAA won't say that. Yes, because as soon as the FTS goes off, whoop, there's an investigation. You got everything gets stopped. You got to check it out. Once they do that, then they could be launching, I would say, almost every 6 weeks. So they at that point, they could be doing it, crossing your fingers that nothing's going wrong, and they can improve the cadence of it and get more and more testing. And then finally, because the next one, if it's successful, successful would be that no rutting at all, and that the first stage booster returned to the Gulf, and they were able to do a soft landing. So, if they're able to do that, and then that's a lot of data. And then they know it's like, oh, we've kind of mastered the control of that coming down. We're pretty good on that. And then the Starship makes it into orbit or partial suborbit. It's like, it's an almost orbit. It's kind of crazy. For all intents and purposes, it's orbital, but it's intentionally designed to decay rapidly in case they lose control or contact with it. We know it comes down. The last thing we want is just like something the size of Starship, just like floating around in space, not under control, low Earth orbit, and Kessler syndrome and everything else going on there. So
we have so many of these missile defense systems at this point that they would just shoot it down.
Yeah, but you don't want to do that. You want the thing to come down on its own, because you make lots of pieces out of it. That's even worse. So my concern was like when it rutted up there, I was like, oh my goodness, I hope all that debris comes down, because potentially you could create a swarm of space junk that's now orbiting the Earth. But
there is
evidently
the calculation, space junk, right, at the moment.
Yes, there's way too much space junk. But evidently some astronomers and others had made the calculation, and they think there's no way, any excess debris should come down within a couple of days or weeks. And they think most of it just kind of came right down with it. So that's a good thing. Then what would happen is it has to prove that it does reentry, and then maybe a soft landing in Hawaii. So, those are big ifs on whether it's able to do the reentry without burning up in reentry and landing. And so, like, if any of those goes wrong, once again, it'll be labeled as a complete failure. Yeah.
Is it correct that both parts need to do soft landing? Yeah.
Yes. See, that's the whole point of Starship, is that
both are reusable, right?
The Falcon 9 is partially reusable.
Yeah.
As impressive as it is, it's not fully reusable. So this cadence that Starship, that SpaceX has done right now, 100 launches this year, that has required them to throw away 100 second stages. They're not reusable. That means they have to manufacture. They have to manufacture 100 second stages with an engine that's being discarded. the idea of the Starship is like, we don't want to have to discard the second stage. And it's been very hard to figure. I mean, getting the first stage booster return is already an engineering challenge. The second stage is way harder. It's a really hard problem. And so they finally figured that out, that this is one potential design that will work. And there are other companies working on other solutions, and it'll be interesting to see what they come up with and whether they're able to do it. But SpaceX will probably be the first to be able to show that they can get full reusability out of it.
Do you
Big
think
question
after,
are the tiles.
yeah, sorry, do you think after that it will be profitable for them?
Yeah. It's especially if they're able to make it reusable. Now,
because at this point, if I'm not mistaken, it's still not profitable, right? He's like at the break even, or
he's
in
break
minus
even right
because
now.
he's paying from it. Yeah.
Yes, there's basically 3 business units within SpaceX. There's the launch provider, which is the Falcon 9 business, and they're doing a lot of that. And I'm pretty sure they're making money on that. They are not acting as a charity. So whatever the costs are to launch a vehicle, they are making sure their customer is paying that much. And the thing is, they're saving the customers a lot of money compared to the standard one. So they're not going to discount it so much that they're losing. So from that, they have enough to partially subsidize the development of the Starship program. Then they have Starlink, which was, it's just the satellite service, and it is able to bring in a lot of money. The question is whether they brought enough in, because what they're doing is they're having to pay the launch provider side of it. So you've got money, that Starlink has to give over to the SpaceX launch provider part. And so like, oh yeah, they're profitable, but they're profitable because of all the money coming from here. And so it's kind of like, robbing Peter to pay Paul kind of thing. It's like, all right, it's going from one pocket to the other. You have to look at it in total. And so it looks like between the two of those things, and the indication is he said Starlink is profitable. So that means that business unit is profitable. And if it's profitable, I'm pretty sure the launch providing part is profitable. And then the third part, which is Starship, that's kind of a separate unit where they are getting a lot of funding. So they've had it's not just Elon. It's like a lot of outside investors are eager. I mean, it's like, if they were to go public offering, man, I mean, people would just buy the shares like that. So the only way to get a piece of it is you have to go through a private investment. And they have no problem. Every time they say, everyone's like, yeah, so the money is going there. This will make them more profitable because they want to put up really big satellites for Starlink. And only Starship can do it. It's only big enough to, because the fairing that you have in the Falcon 9 can only put in something so big. Mm-hmm. And they need something even bigger than that to be able to get these satellites up. So they'll go up, and they'll go up a lot cheaper. The big question is whether they can really turn it around that quickly. Whether they can get the launch cadence quick enough that you'd be able to do it, and whether, Elon would like to turn around in a couple of hours. Okay, someday that's going to happen. But, right now, I think the Falcon 9 is able to turn around in under a month. It might be like 21 days, might be the best one, but it used to be a couple of months. The space shuttle, oh yeah, that was supposed to be every 2 weeks we're going to be launching. That's what we were promised. And then it was like 6 months or more. There was like a lot of refurbishment and everything else. And the shuttle was going to bring the prices down. It never lived up. But actually, if you look at, I think you actually tweeted out a post on that. And I was looking at it. It's like, oh, wow, the shuttle actually increased the cost of going to space. That didn't bring it down like we were promised. Like what was going on there? So yeah, the big question is whether they could do it, because if you're not throwing something away all the time, and let's say the maintenance is not really tricky, if you're able to do it without a whole lot of effort doing it, then all your cost is fuel. And that is so small compared to like throwing everything away. And then the price just goes way down, and then everything's going up. And then at that point, business opportunities will just open up like crazy, because they're always entrepreneurs. Mm-hmm. They're sitting there saying, oh, if I could afford to put something up there, what would I do? And everything from like space tourism to putting hotels up there to some kind of manufacturing, Elon has said it's like the Wild West. Once the train was established between the two coasts, that just changed everything. And so he's creating this train that's going to bring everyone up into orbit. And then there's only one train in town. So who are they going to pay? It's like,
yeah, I wonder if there will be more trains. Are we going to expect like new Elon Musk or more Elon Musks to shortly come on the stage?
Yeah. And I think there's a couple out there already.
Yeah, we have Joseph. No, Best Jesus.
Jeff Bezos.
Jeff
Okay.
Bezos.
Unfortunately, he's really underperformed in that area. I think everyone's severely disappointed that they started before SpaceX and they still have not made it to orbit. And New Glenn is years behind, and I'm not holding my breath on that going on. But you have another one, which faces. Is well, you already have a new face that's been around for a couple of years now, and that's Rocket Lab. And Rocket Lab is a successful startup. They are launching payloads out of New Zealand and out of Wallops. They're starting to do recoveries, and they're a smaller launch provider, so they're not as big as Falcon 9. And Peter Beck is the head, and he is quite sharp and quite smart and knows what he's doing. And so I'm impressed with him. There's Relativity, which is another one behind me. I think is it Astra is another one. There's some other startups. There's also Stokes. And there was an interview with the CEO of Stokes. I believe his name is Andy. I forget his last name right now, but it was Everyday Astronaut did it. Very impressive. I mean, what he knows and his background, his experience. So there are a lot of other startup companies out there that are doing it. And I think they will be successful for a couple reasons. One, so many engineers are now getting degrees in aerospace. They've seen how some of these problems have been done. All the stuff that SpaceX is doing right now is being taught in graduate level classes right now. So other people can come in and sort of build on top of that legacy very easily. So there's enthusiasm. There's the realization you actually can do this. And what that means is that there's venture capitalists who are more than willing to invest in that. So now that they've seen it, they're like, whoa, we missed SpaceX. It's like, where's the next one? And they're probably looking around for that. And so they want to get in on that as well. And so there's kind of a gold rush, and you're going to see more and more. Whether it's Blue Origin, at this point, I just don't know. It's like they've got some impressive designs. I'd like to see it fly. Just I don't know why it takes so long.
How about Axiom?
Yeah. Okay. Axiom, they are... I don't think they have a rocket, but they are the ones that are setting up like these labs and habitats in space. So they are actually paying to have astronauts go up on the Dragon. Yep, they go up there with the idea that eventually they want to set up these inflatable habitats and everything else that will become these hotels. And I think they're working on the orbital reef. So they're one of the groups that was in there that included Blue Origin for a while, and then Blue Origin said, "Nah, we decided not to do it." So they want to create the next generation satellite with some ideas. So again, there are those companies that are trying to find out, well, we're not going to build the rockets. At this point, let's figure, we don't need another launch provider. What we need is new ideas of what to do once we get into orbit. And okay, there's going to be competition. Eventually Blue Origin, or I should say Amazon, wants to put up their Kuiper satellite network, which will compete with Starlink. Well, OneWeb is up there as well. So there's others that are potentially trying to do that. But I mean, how many of them do you need? It's going to be like three or four.
3-day delivery.
And I think China is putting up their own, So there's going to be other countries that are going to be wanting to, but at some point it's going to be, all right, we got more than enough. We don't need more internet satellite providers. Let's come up with something else you can do in space. And some of it will be pharmaceutical production and microgravity production and production of pure crystals and stuff like that, because there's two things that orbit provides you. One is like 0G, and the other is like about as pure a vacuum as you can imagine. And so there's some things that you can only do in a pure vacuum. And then there could be all these other kinds of experiments, kind of astronomy that would be going on, as well as, just recreation. I have to ask you, I'm going to turn the tables here on you. Is like, Lenka, if you had the opportunity to go into space, would you go?
No.
No.
Really?
That's a firm yet?
That's a firm yet. I would love to have the courage and braveness to actually go there, as you probably do have. But me personally, I get sick when I turn around for a minute, so let alone if I would be in a rocket. That's probably what's stopping me. I can't go to the children plays ground, and use anything there because I get too dizzy. But I know you mentioned that you would like to go, so at least one of us. Absolutely. So I think I joked the other day on the Spaces that if Tim Dodd's having second thoughts, I'll replace him. Yes, that's the interesting, right? The Dear Moon project, which
Mhm.
the Japanese billionaire, I will not try to pronounce his name now because it would be even worse than Amazon chief. So he paid this. I forgot how much it costed, but he basically is funding this whole
Mhm.
program to go around the moon, right, for seven
Yes,
days, if
yes,
I'm not
yes,
mistaken. And
yes.
the interesting part, I personally thought is interesting that he picked all of them are artists. So he intentionally picked people who are like one of them is a dancer, one of them is a DJ, another one is singer. So like a group of people who, there's really no one who is a professional astronaut.
Yeah, and that's I think it's very important because then it starts to democratize the access to space and makes people more enthusiastic because they will be able to explain their experiences better. So
Mhm.
every astronaut that went up there and cosmonaut said that it changed them. It changed their viewpoint of the Earth. They were there's something else, but a lot of them couldn't articulate what it was. There were a couple of Apollo astronauts, I think Edgar Mitchell and even Alan Bean. They took up art and like when they came back, they were just painting, and so it just like sort of changed them because they had this I think it's called
Oh.
like the overview syndrome or something like that. Um, so now imagine you take people who are like you say musicians and dancers and someone who is a
Yeah,
videographer like Tim,
inspiring
who
them. Yeah.
documents it. Yes, there was like discussions way back in the 80s before the Challenger disaster that there was this very famous American journalist Walter Cronkite who he just loved the space program, and he was the voice you listened to when you were watching all the Apollo launches.
Mhm.
He just was, and everyone just considers him, one of the greatest journalists of all time. And everyone just felt that he should get a ride into space. He was like the first journalist that wanted to go up there, and he probably would have very soon because that launch was they were putting the first school teacher in space, Krista McAuliffe,
Mhm.
and then the disaster happened, and then it was like after that, it's like, oh,
No,
no,
I
we're
will
not
stay on the
putting any
ground.
citizens up again. It's just it's too risky.
Yeah.
But more than likely, a journalist would have gone, and everyone would have said, "Yeah, Cronkite,
Mhm.
he's going to be the one to go,"
Mhm.
just because he could probably explain it much better. And it seemed like of all the people that brought it to our living rooms and sort of pushed it forward, he was very important. So now, in a way, Tim Dodd is like it's the Walter Cronkite that we're looking for because he is clearly one of the best space journalists out there, and he doesn't work for the official mainstream media. And everyone just recognizes that Tim loves all space. He loves all the different companies out there. He's able to explain it partly because he didn't understand it himself, and in the process of trying to understand it, he
Mhm.
realized, oh, this is how you're able to. So he's not explaining it like a rocket scientist because sometimes this rocket scientists will just get off the handle and like, what are they talking about? I have no idea.
Yeah, I think he used to be a photographer, right? If I'm not
Yeah,
mistaken.
yeah, and a musician. Yeah, so a photographer and a musician, and I think the funny story about him is he ended up finding a cosmonaut suit online. He ended. Did you ever see that? Did you know
No.
that story? Yeah. So what he did was kind of like a gimmick that he discovered that he was able to buy a used cosmonaut suit, the bright orange suit and everything online. He got it. And he used to do all sorts of videos with that, like, him out there. And this is where the everyday astronaut persona came from, is like he was pretending to be an astronaut in a spacesuit out mowing his lawn. So he did like some video on that, and it got like lots of likes and everything else. And he started just doing other things of what it'd be like to be an everyday astronaut in these everyday kind of situations. And then he started getting like an interest in the history and started explaining it and then going through it. And he'd say, oh, guys, I just discovered, this is like really cool. I just learned about this, about the Gemini program, and I just have to tell everyone. And so he would go
Yeah.
on, he just started producing those things, and they were made so well. And even though I knew that history and understood it, I love going through and seeing Tim's enthusiasm on that as well. It's like, oh, finally, someone's explaining this to everyone else. We're going to have a generation of people who love space.
Who
And
will
so
understand the space.
yeah, he's brought us all along for the ride, no doubt about it.
Yeah, on that note, as he's part of the Dear Moon project, I wonder how they feel when they see these rockets, blowing up. How much, do they have to take some antidepressants right after?
Well,
Like
the astronauts went
everybody.
through the same thing. The Gemini or the Mercury astronauts, it was the same thing because they were down at the Cape watching a lot of those rockets blow up. A lot of them. So they'd be sitting there. Here's a test launch of the Atlas Mercury, and then boom. So there's
Like,
plenty of
of
footage.
course, we understand it that it's just a preparation and that they are still
Mhm.
studying it. And we all know that. But like just the fact of seeing it,
Yeah.
because some people are scared of flying, and yet
Oh yeah. Yeah.
planes really
Yeah.
don't fall. You don't see them
Yeah.
falling. If you see
Yeah,
plane falling,
you don't see them, but you got to remember the reason why they don't fall out of the sky, because
yeah.
there was a lot of tests where they did, and unfortunately, a lot of those tests involved test pilots. So the reason why airplanes are so safe as they are today is because we owe it to these brave men and women that sometimes went up and were flying an experimental vehicle and pushed it to its limits, and they weren't able to come back. So there's a lot of those things, but from it we've learned, and that's why everything is safe. I think at this point, test pilots, it's not quite as risky as it was back in the 40s and 50s, but it's the same kind of thing. You see that, and it's going to be a while probably before Starship is human rated anyway. So I think it's not like it's going to be in 2025. It's probably going to be a little bit beyond that, but eventually they'll be able to do it when they've been able to prove that they can launch up there, come back, everything is safe, that the heat tiles aren't falling off. Because that's my biggest concern, is like the tiles were still falling off, and we hadn't even, that was on the way up, and we're not even know what it's going to be like on the way down. Yeah. Yeah. And you got to make sure, because when you're going to Mars, everyone's going to be saying, oh, the heat tiles, I hope they're still on. We've been 9 months out here. Are they still on? So they have to come up with some way to make sure that those are going to be really durable. Because that was the Achilles heel. Yeah. That was the Achilles heel of the space shuttle program. In that, the Columbia disaster was the heat tiles falling off, because the heat tiles were getting knocked off every now and then during the launch phase. But the biggest thing is they were so difficult to maintain. I mean, it was just, they had to come back and inspect every one of them, and every tile was unique. So it's not like you just had over there a rack of like 300 tiles that you could just use anywhere on the shuttle. It's like, nope, every one of them was different. And the way to put them on there, it just was painstakingly slow. And that's why the turnaround time was very, very slow. So they have to solve that in Starship if they want to be able to have a quick turnaround. And they're going to probably have to come up with some different sort of heat resistance on there, the heat tiles. I'm not sure what it's going to be, but I'm not 100% sure this is going to work, just because they seem very fragile, very, very fragile.
And how do you think is realistic the Mars trip? We are talking about around 2030, but there's not only the fact that about the rocket itself, right? We also need to consider the health of the astronauts. How do you actually do anything on Mars? How do you do it with energy and food and all that? I know that Elon Musk has been floating some ideas, and they sound, of course, very smart. I just wonder how all these different pieces, which are in a way very difficult to do separately, how they will come together and enable us this Mars trip.
Yeah, the Mars trip is far enough away that a lot of those problems will be solved, because there are a lot of people already tackling them. So, within SpaceX, they have people looking at the problem. Elon's brother Kimball is looking at hydroponics and other ways of being able to grow food that would be applicable on Mars and also the moon. And then you have the Mars Society, which is looking at habitats and everything else. Robert Zubrin's group that is clearly going through and trying to figure out what's the best way to get there. So they're all solvable problems. They are challenging, but I don't think it would be that difficult to actually send crew to Mars and be able to have them come back. Colonization is going to be a much bigger step. So we were able to have, scientific research stations on Antarctica, but as you can see, we don't really have a colony there.
Yeah.
And that's really pretty close because of the harshness of it and all the supplies you have to bring in. So there's two possible scenarios. The classic scenario is that you send a small crew of maybe up to 6. You land there, you spend either a month there or a year and a half. So, I mean, those are the choices you have, depending upon the windows that you use to launch up there. You might be able to go up there, stay for 30 days, and then you have to return right away if you want to make it back to Earth. Otherwise, you have to wait, I think, almost 18 months before everything kind of gets itself aligned again, that you can do the return. Okay, so, and then
18 months, wow.
18 months. So you'd have to be able to stay there 18 months.
That's
it's either 30 days or it's 18 months. Okay. And NASA already looked into that back in the 60s, because in the 60s, they were thinking, well, what's next after the moon? And then they already lined out, it's like the year is 1981 and they got ready to go. And so they had it all mapped out. And they were seriously thinking of like the 18-month stay with crews that would, I think like 2 crews that were going to be in Martian orbit. Some would go down, spend a little bit of time and come back up. So they were like trading back and forth and making sure that the return vehicle was, properly maintained and all that. But they figured out that you would have enough supply to do it for a small contingent of people. If you want to have a much larger number, then it becomes hard. And that's why you need to have like 1,000 starships. So the problem is you don't have this pipeline of stuff going to Mars. You have like these fleets that are sent out every 2 years, or actually worse than that, 25 months that you'd be sending out. So if you need to get help, and you're going to have to wait a long time, or if you need like resupplies, the supplies are going to be coming every 2 years. So you got to make sure you're sending that amount of material to be able to keep everything fostering on. Mm-hmm. So one way is that you go there and you figure out how to come back home. You just send a crew there, they do some science, they come back home. And so that would be about a 3-year round trip overall.
Wow.
And you might be able to do it, but they're going to have
crazy.
to. Yeah, it's crazy because of that, they're going to be spending about half that time in weightlessness.
Yeah, and we know that. We know that
and
6 months in weightlessness can cause like bone damage and all that.
Yeah, a lot. And then, so just imagine now we're talking about 9 months and you're recovering in a 1/3 gravity well as opposed to a full G. So you get a little bit of maybe recovery from that, but not the full. So we just don't know. There's going to be exposure to cosmic radiation, but that can all be dealt with. There's ways of doing a shielding and everything that can be done. It would be a bit expensive. And then you just have to make sure you have enough consumables for the crew and primarily food. You got to make sure enough food, and can you? It
doesn't go wrong in 3 years,
right? And the food needs. If you're going to be growing food, you're going to need water. So you're going to either have to recycle water or you're going to have to find it locally. And oxygen, and all those can be produced locally on Mars. That's Robert Zubrin's idea of in situ resource utilization, where you can extract the oxygen from the carbon dioxide that's already in the atmosphere to produce breathable oxygen. Hopefully there's enough water ices underground, stuff like that we might be able to get the water that we need for drinking water. Otherwise, you actually bring hydrogen with you, which is already pretty hard to bring. It's very light, but still boil off issues. And you use that hydrogen to manufacture water on the surface of Mars, and you have to recycle it. And that's tricky because there have been these habitats that have tried to be enclosed to see if everyone could live in there with just like a big greenhouse and everything. And it never quite worked. The carbon dioxide levels got a little bit out of whack that they had to vent it. It's like, it's one thing you're on Earth, you can get away with it. But when you're on Mars, it's like, it's like, we got a problem here with our atmosphere. We can't keep things under control. So that they have to nail down. You have to be able to produce the food. I believe it can be done. I mean, it's going to be dangerous. It would be great if you could do it and people survive there and back. There's always a possibility that something could go wrong and has gone wrong in space before. But I think it's worth it. And the people who do it would be up for the challenge. And then there's the other way of doing it, which is even crazier, because trying to come up with a return trip requires also a lot of extra mass and a lot of other complicating factors and all. And if you're going to Mars for about 18 months, I mean, you're to the point that you should just, if you can survive there for 18 months, you should be able to survive there for at least 18 years. Mm-hmm. So what you would do is you would find people that are, let's say, more senior in their age, and maybe have a strong background in like biology and geology and, and the different kinds of sciences that you might want to have up there. Maybe know a little bit about medicine and basically because of their profession, they're always out in the field a lot. So they're used to rugged terrains and camping and stuff. And maybe they don't have a close family or anything like that. They don't have these close bonds. So they would probably be up for this. And I remember pitching this idea to my brothers like years ago, and they said, "You're crazy. No, I don't want to do that. Who would want to?" It's like, it's absolutely crazy. And I said, "Okay, I'm not bringing that idea up again." And then, sure enough, a few years later, Lawrence Krauss from the University of Arizona State University, proposes the idea of like a one-way trip. And I'm like, "That was my idea." And I didn't tell anyone. So, and the idea is that you get people that are not in their 30s, because like you send someone in their 30s, they're going to be regretting when they get there. They realize, "Oh, there's nothing here. I really wish I had a family, or I miss my family, or this and that." You get healthy couples that are in their 50s or 60s that, have all this experience and stuff. And they go there, And so they get to survive, the remainder of their years there, 10 years or something like that, doing science, doing really, really great things.
But
And they can either be
50s and 60s, these days people live until 80s, 90s, right? Still
Yeah,
young.
so they
in
do, but I
50s.
mean, for a lot of the people getting up in that age, in many cases, their universities and stuff are just trying to kick them out. They're just trying to say, "Oh, isn't there time for you to retire?" I mean, it's like they're just like trying to push them out the door. And it's like, "But they got all this experience." It's like, "All right, let's take that experience and do something else with it." And if you ask them, and really, and it turned out, I think it might have been the Mars Society or one of the others proposed that idea, and they got applications. And they had like 300,000 people said, yeah, they would do that. They would go to Mars one way. So they're
Wow.
Now these people, you probably have to do a lot of psychological screening on because some of them are probably a bit nutty, but some of them I would think, would really be serious because they mostly spend their time out in the fields, out in desert areas or high mountain areas or something like that. And yeah, why not? If they want to, you just need to be able to make sure you could make that they would be able to survive. And you just keep on, make sure every 2 years they get resupplied. And, this concern is like, well, yeah, maybe they perish on Mars, but, they were 75. Well, that happens all the time on Earth. It's like they lived a good life. They would have absolutely no regrets. And at this point, you send a 30-year-old up there, they come back home, they've been exposed to all sorts of things. They develop a cancer when they're 45. That's tragic. You send someone in their late 60s or 70s and they spend up there doing great stuff. And then, okay, they get a bit sick. It's sad. But at that point, it's no longer a tragedy. It's just more like, they lived a good life. They lived the life they wanted. And they actually gave something. Yeah. So I know people look at it and say, that's a bonkers idea. But it's not like we are drafting people and forcing them to go there. It's like,
I know one of the ideas was also to send prisoners, right? Like to make it.
I think some people brought that up as a joke. That was a joke in the spaces because that's what the British did in Australia. In order to get the colony set up, they did it. And it's like, no. It's like, no way. You're not sending prisoners. I'm going before them.
Some people would be probably up for it, right? To get out of the prisons, and sometimes they are in a great physical shape.
And I think The Expanse and other science fiction movies kind of looked at it that at some point, but that's when you're at the point that you really can colonize a place and that you need a lot of that excess labor. But the early ones are it's not going to be a prison population or anything like that. You're sitting it's going to be people who are probably very scientifically literate and are going to be there for exploring. And they're going to be looking for life. They're going to be looking for signs of water. They're going to be looking at the geology to try and understand what's been going on, get an idea of what's going on in the atmosphere. So you're going to need a scientific contingent there, but you're also going to need the other people that do whatever to kind of keep everything going. So you need like a good mechanic. You're going to need a doctor, but they're going to be dual purpose. So you're going to have someone, probably at least two people that would be able to act as physicians, but also act as like a botanist or a biologist or something like that. So they would have kind of that dual degree. And so, you might have a mechanic that's there that's because he's got to figure out how to do this stuff. You might have someone that's like a botanist farmer type of thing. So you would kind of look at the kind of people that would make sense to be able to keep the colony going to provide what it is. So there'll be a scientific outpost at first. And then eventually it might be able to expand. And then you can start saying, oh, we can start creating the infrastructure for a bigger settlement. And that's probably where the robots come in, because the robots would be more effective than just saying, let's get a chain gang and send them up there and like force them to like prepare everything for our billionaires who are going to be coming on the next flight up there. It's like,
well, they could be even the first ones if they, if we get the robots far enough.
Yeah, the robots make sense because the problem with sending any people up there is the consumables. You have to keep them alive. And that means air, water, food. They need rest, all these other things. They need entertainment. But the bots, nope. All you have to do is make sure that they're able to survive in those rugged conditions, and they'll give you 24/7, and you can send way more in one starship than you can send humans, because humans need everything like that. They need the water, they need the air, they need the sanitation, they need the food, they need adequate space to be able to move around. They need to be able to exercise. All that.
Yeah, especially if you spend there 3 years.
Yeah, the bots, you just fold them up, and however many fit in there, you can go ahead and send them. So, you might be able to send 100 people there, but you could probably send thousands of bots in the same ship.
As long as they don't make some kind of spoil robots, who will require all these human activities too.
Yeah. So, well, yeah. Who knows? Maybe the robots eventually they get so clever they're bored also, and then it's like, but because they're going to have to be
smart enough to
they
sort
have
of
to be smart. Yeah,
yeah.
no doubt about it. And
So if they will be smart enough to survive on Mars and build everything, will they be like, doing us something which we didn't want them to be doing, probably, right?
I know they're going to be there 2 years all alone. Who knows what they'll come up with? And then suddenly they show up and they're like, "Oh, yeah, go over here. I want to show you something."
Well,
nice ravine, huh?
Scott, if I can now move probably to the last question.
Sure.
It's been really interesting, so thank you for that. But I was also wondering what you think of, Russia, China, and other countries. Because now everything is centered on the United States mostly, but how about the rest of the world? And also, why do you think that there was such a huge gap? We also spoke about it in the X Spaces. Why there was such a huge gap between when we first landed on the moon in late 60s versus 50 years later, and we are, blowing up rockets to try and land on the moon? Was it the space race during the Cold War? We mentioned not enough money. So, how do you think all this coming together, in the history we did it, and Russia and China and the United States, and how about now, how these countries are they going to compete again? Sort of long question, but hopefully got it.
Yeah. I mean, competition is good. So there's no doubt about it that the thing is, no one understood what was the point of going to the moon. It was just to prove that we could do it, and we brought back a couple of rocks and so on. So there was no economic reason. If they had discovered gold on the moon or something like that, believe me, we would have stayed.
Right?
We would have stayed. So there wasn't anything that was obvious that was any sort of benefit. It was like a scientific curiosity. We had enough problems back here on Earth. The Vietnam War was still going on. We were having our war in poverty. There was all these sort of other things. And okay, we went ahead and did it. But to do that, NASA was like 6% of the U.S. budget. Now it's like, I don't know, 0.1%. It's a very small amount. So there was like a lot of money that was spent there, and people were not willing to do that anymore. So no, that's. And then the shuttle came along with the promise, like, well, it was going to make everything cheap. And then it just ended up being this big drain, and we just ended up in low Earth orbit, and just decided that we wanted to study more of what was going on Earth, and long duration flights and stuff like that. So before you could even consider sending anyone to Mars, you have to understand, like, well, can we survive a year in space? So it did kind of make sense to do that. But the moon no longer became sort of an object or a goal. And I think that whole generation wasn't really that interested in. It's like, oh, great, some people are just orbiting the Earth. We've done that, since Yuri Gagarin. So what's the big deal? Now they're beginning to understand it a bit more, because there were a lot of companies that were trying to do it. So I think it was first Kessler Aerospace tried to do it privately. There was, I think Boeing had done some spinoffs, and others that were trying to also do it. And then there was another company called Rotary Rockets in the 90s that was also trying to work on a reusable rocket system, but they all ran out of money, and they had these grand designs that didn't work. So when SpaceX came along, I was so jaded looking at all the others and like, oh yeah, seen this movie before. Wish them luck, but they're probably not going to do that. And then to see that they were actually doing it, like when I first saw the grasshopper going around and going, it's like, these guys are serious. They're really going to do it. And then before you knew it, they were up to had the Dragon going up there. So the thing is, if you take SpaceX completely out of the equation, the American space program is a joke compared to Russia and China. And then if you look at where China has gone, is China went from they had absolutely nothing that they are accelerating. They have so many different vehicles. They are launching all the time. They have just built their own space station. What they've done on Mars, what they've done on the moon shows that they are serious and they are not slowing down. And in some ways that's good, because I want to see, everyone wants to see the O'Neill cylinders and hotels in space and being able to do a vacation to the moon or something like that, or at least broadcast from the moon. We should look at it not that China has returned to the moon, or Russia has returned to the moon, or the Americans have returned to the moon, but that humanity has returned to the moon. Okay. So I think, the answer, who was the first person to walk on the moon? You could say the first person to walk on the moon was Neil Armstrong. And that's the correct answer. Or you could say the first person to walk on the moon was an American. I'm like, no, no. It's like, again, he didn't represent the United States. He represented humanity. That was the whole point of those steps, is that it proved that we could do it. The whole world was able to celebrate. It was done by the American space program. Yes, that's a fact, but objectively, that's how you want to look at it, is that those are the first steps for humanity on a surface outside of planet Earth. And the same thing with Mars and all that. So if you need the competition, if you need the rivalry, okay, I'm all for it. I'd rather see cooperation like we've seen at the International Space Station, that we kind of join forces to solve all these different problems to be able to do it. Because it's going to be for the benefit of mankind, or humankind, I should say. It always has been, because of the technologies we've been able to develop and what we've been able to learn and what we've been able to push forward. So it's frustrating that it's taken this long, because I expected that, this time in my life that we'd already be at Mars and things going beyond there. We'd already have because I really thought that 2001 A Space Odyssey was what it was going to be like. Yeah, we'd already have, this big base on, what was it, Tycho crater or something like that. And already getting ready to send ships out to Jupiter and all in 2001. It's like, well, Arthur C. Clarke was like off by quite a bit, at least 50 years, hopefully not more.
Perfect. Thank you so much, Scott. It was very interesting.
Yeah.
Really, thank you. Wow. I think I learned a lot, and everyone will. Thank you for that.
Yeah. You're more than welcome. So I can say, So
see you in Mars.
Yes. At some point, we'll see you in another